Azure App Service is a fully managed platform that enables you to build and host web applications, mobile backends, and RESTful APIs without needing to manage infrastructure. It seamlessly integrates with tools like Azure Resource Manager, ARM, templates, bicep files, and the Azure CLI. This service inherits concepts from previous modules, such as virtual machine usage scenarios and container-based deployments. It simplifies operations by abstracting away the underlying maintenance. Through App Service, you gain built-in load balancing, continuous deployment options, and detailed monitoring capabilities. It caters to multiple programming languages, making it highly flexible. By understanding its key features, you can efficiently deploy and manage scalable applications. Azure App Service supports a variety of runtime stacks, allowing applications written in .NET, Node.js, Python, Java, PHP, and more to run in a managed environment. Each runtime can be configured and updated through the Azure portal, Azure CLI, or ARM-based scripts, closely mirroring the approach used with virtual machines or container instances. This flexibility eliminates the need to maintain separate server environments for different types of applications. In this way, developers with diverse skill sets can conveniently deploy code, enhance productivity, and reduce compatibility issues. By selecting the desired runtime stack, you ensure consistent performance and streamlined application development. When creating an app service, you could deploy your application code using various methods. For example, you can utilize the Azure Portal's Deployment Center, which offers integrations with GitHub, Bitbucket, and Azure repos for automatic builds upon code commits. Additionally, you can use the Azure CLI to push code packages or container images directly to App Service. Another alternative involves deploying resources using ARM templates or bicep files, which automate creation and configuration steps to ensure a replicable environment. By merging these approaches, you can achieve faster and more reliable deployments, preserving compliance with organizational standards and development best practices. Upon provisioning, you can configure an app service to match specific application needs. Settings include custom domain bindings, SSL certificates, environment variables, and application settings. The environment variables can store secure data, such as database connection strings. You can also define deployment slots to test new versions of your application before production release. Integration with services like Azure Key Vault streamlines secret management, aligning with best practices covered in earlier sections on resource governance. All configurations can be managed either through the Azure portal or through ARM templates, ensuring consistent and auditable deployments across different environments. App Service plans determine the compute resources and pricing tier allocated to your app service. Options range from free and shared tiers, suitable for small-scale or experimental projects, to basic, standard, and premium tiers supporting higher traffic and advanced features. Here is a brief table of typical tiers. Tier features: free limited CPU/memory basic dedicated compute standard auto scaling, daily backups premium high performance. SSL, selecting the right app service plan ensures appropriate allocation of CPU, memory, and scaling capabilities, enabling cost-effective and optimal application performance. Azure App Service seamlessly integrates with continuous integration and continuous deployment (CI/CD) pipelines. By connecting your application to a source control repository, builds can automatically initiate every time new code is pushed. Pipeline tools such as GitHub Actions or Azure DevOps allow for automated testing, artifact generation, and final publishing steps in an app service. This reduces human error and ensures consistent code quality before applications go live. Additionally, deployment slots enable you to swap environments without downtime, further enhancing the risk management strategy covered in previous modules on ARM-based deployment processes, providing a robust ecosystem for iterative development. App Service offers various networking features, including the ability to restrict traffic to private endpoints, integrate with virtual networks, and establish IP restrictions. You can configure traffic routing rules to control inbound requests or connect securely to on-premises resources using hybrid connections. Additionally, You can enforce HTTPS for all requests and upload SSL/TLS certificates for custom domains. App Service also supports managed identity, enabling secure communication with other Azure services without embedding credentials in code. By leveraging these networking and security settings, organizations can maintain a protected environment in compliance with broader security policies and best practices. Beyond traditional code deployments, Azure App Service can host containerized applications by pulling images from sources, such as your Azure Container Registry. This approach merges the familiarity of containers with the streamlined management provided by App Service. You can define your container's startup commands, environment variables, and networking configurations directly in the platform settings. Incorporating container builds into your Azure DevOps pipeline or GitHub Actions offers a unified workflow that parallels the use of Azure Container Instances or Azure Kubernetes Service. This container support ensures you can maintain portability while relying on App Service's built-in scaling and monitoring. Azure App Service supports both manual and auto-scaling mechanisms based on metrics such as CPU usage, memory consumption, or HTTP request volume. By configuring auto-scale rules, you can automatically adjust instance counts to handle fluctuations in workload, maintaining consistent performance for end users. To track application health, integrate Azure Monitor for real-time telemetry data, logging, and alerting. You can also use application insights for deeper diagnostics, including distributed tracing and advanced usage analytics. This approach aligns with monitoring practices outlined in earlier modules, allowing you to proactively optimize performance while identifying potential issues across your environment. When creating an app service, performance optimization begins with choosing an appropriate app service plan, followed by employing best practices such as caching, efficient session management, and asynchronous code execution. By distributing workloads across deployment slots and scaling based on specific metrics, you reduce resource contention. Additionally, incorporate Azure Content Delivery Network, CDN, to offload static content delivery, and use Azure Redis Cache for improved data retrieval performance. Integrating these techniques with proper logging and monitoring ensures your app service remains responsive and robust, meeting the tight demands of modern cloud-native applications. Each step contributes to smoother, more secure operations.